Hi everyone, so welcome back to my new video. So today in this video, I'm going to discuss about a small concept in principle of communication systems. So myself, I'm Santosh Kumar. So let us dive into the topic. So the topic is AM diode modulator circuit. So the introduction. An AM diode modulator circuit is used to combine audio signals with a radio frequency carrier wave for amplitude modulation. So this modulation technique is essential for broadcasting audio signals over radio waves. And the circuit typically consists of a diode, audio input, RF input, and output components. Okay, so the basic components of AM diode modulator circuits are: the key components includes a diode which acts as a non-linear element for mixing the audio and RF signal. And then an audio input is connected to the modulator circuit to provide the desired audio signal for modulation. And then finally the RF input delivers the carrier wave signal that will be modulated with the audio signal. And then working principle of AM diode modulator circuit. So the diode in the circuit operates in a non-linear region, allowing it to mix the audio and RF signal. When the audio signal is applied, it causes variations in the diode's conductivity, resulting in amplitude modulation of the RF signal. The modulated signal is then outputted for transmission over the airways. So in the simple ways, it involves like combining signals, nonlinear mixing, filtering, and finally output. And then the advantages of diode modulator circuit. So it is simple and cost-effective design compared to other modulation techniques, provides efficient modulation of audio signals onto RF carrier waves, and finally well suited for applications where high fidelity is not a primary concern. So some key benefits of these modulators are simplicity, energy efficiency, good linearity, high power output, and high speed modulation. And there are few disadvantages of AM modulator circuit. So those are limited in terms of modulation depth and fidelity compared to more advanced modulation techniques, susceptible to noise and interference impacting the quality of the modulated signal. And like mainly the other disadvantages are power efficiency, bandwidth requirement, non-linearity and distortion, carrier suppression, modulation depth, and component sensitivity. And then applications of AM diode modulator circuits. So here are some common applications. Those are radio broadcasting. So they are widely used in AM radio broadcasting when the audio signal modulates the amplitude of the carrier waves. And television broadcasting. In television, they can be used for transmitting audio signals alongside the video signal. And then two-way radios. These circuits are also found in two-way communication devices such as walkie-talkies. And then shortwave broadcasting. AM modulation is sustainable for long-distance shortwave broadcasts, including international broadcasting and ship-to-shore communication. And communication systems. They are used in various communication systems that require amplitude modulation for signal transmission. And then types of diodes used in AM modulator circuit. So those are commonly used diodes include germanium and silicon diodes for their nonlinear characteristics, and Schottky diodes are also utilized for their fast switching speeds and low capacitance. And finally, varactor diodes can be employed for frequency modulation applications in the modulator circuits. And here you can see some the types of diodes which can be used. And then circuit design consideration for AM diode modulator. So proper impedance matching between the audio and RF inputs to optimize modulation efficiency, and then selection of the diode type and biasing conduction to achieve the desired modulation depth, and finally filtering components may be incorporated to remove unwanted harmonics and noise from the modulated signal. And let us compare the uh, comparison of AM diode modulator circuit the other modulation techniques. So AM modulation is simpler than FM or PM modulations but lacks in fidelity and efficiency. FM modulation offers better noise immunity and audio quality but is more complex to implement. Okay. And then PM modulation is used in phase sensitive applications where phase information is critical. And then real world examples of AM diode modulator circuit applications. So those are emergency broadcast systems that rely on AM modulation for widespread communication during disasters, and aviation communication systems that uses AM modulation for air traffic control and pilot communication. And the other are military applications where secure and reliable communication is essential for utilizing AM modulation for simplicity. And then challenges and limitations of AM diode modulator circuit. Limited bandwidth and frequency response compared to other modulation techniques, and susceptibility to signal distortion and non-linear effects in the modulation process, and adverse effects of multi-path interference and fading in long-distance transmission using AM modulation. And then innovation in AM diode modulator circuit technology. So what are the innovation can be done in the AM diode modulator circuit? So those are integration of adaptive modulation algorithms to enhance signal quality and efficiency, and exploration of advanced diode materials and structures for improved modulation performance. And then finally, implementation of machine learning techniques for automatic adjustment and optimization of modulator circuit parameters. And finally, what we can say about these AM diode modulator circuit, like AM diode modulator circuits play a crucial role in transmitting audio signals over radio waves, and they, despite limitations, AM modulations remains a widely used technique in broadcasting and communication systems, and continued research and innovations are essential to enhance the performance and efficiency of modulator circuits. So these about the topic, and thank you for watching the video. Thank you.